So looking at number 4 off of your quiz, this is one that a surprising number of people weren't able to get all of the parts correct on. So I want to definitely make sure we're going over this. You're just supposed to tell how many solutions we have. So I'm going to look at each one's component parts, starting with the fact that this first one has a slope of 13. The second one has a slope of 13. That tells me that I don't really know what these would look like, but they're going to have identical slopes. Then when I keep reading, one has a y-intercept of -3. The other also has a y-intercept of -3. So they have the same slopes. If I would take these and move them onto some graph paper, they're going to have the exact same y-intercept and they have the exact same slope. So they're the exact same line. You can't just pick one spot they have in common. There would be an infinite number of dots that are on both graphs. So this first one should have been, it's a checkbox that my paper doesn't let me see, so I will just write in infinite solutions. So then the next one, when I read it, it tells me one equation has a slope of 4/3 and the other has a slope of 3/4, which if you think about it means one went up 4 and then right 3. The other only went up 3 and right 4. The steepness of these lines is not the same. So even if they have the same y-intercept, because these do, so let's say these have the same y value here, they're not the same line. They don't have infinite solutions. Because the slopes are different, they will cross exactly one time. Every pair of equations that have different slopes will have exactly one solution. So this last one, we are given a problem that has a slope of -3 and another one that has a slope of -3. So they are both decreasing at the exact same rate. The y-intercepts are known to be different. So don't even bother to tell us what they are. But wherever one of these crosses the y-axis, the other one is just somewhere else, which means these lines will never cross. There is no solution to this last one. So definitely try and picture what's going on if you haven't yet memorized that, oh, different slopes means one solution. And rather than memorizing it, try and just picture it maybe. That might lead to a higher success rate for some of you guys. So then number 5, given the system of equations, I'm going to use graphing technology to determine the solution. So this is going to be a bit janky because I don't have a graphing calculator on my iPad, which is how I'm currently recording this for you. So what I am going to do is attempt to just -x plus 4 and 4x minus 1. Okay, I'm going to try and memorize that so I can do this. So I'm just going to hold you up to my iPad. So as a reminder, when you need to see this graphing calculator, I'm not on a Chromebook, so mine doesn't look the same, but you should see a circle right here called the launcher. And when you click on that, it pulls up this like a menu at the bottom of your screen, and you could type in like TI-84. It should pull up essentially this. It won't be a whole screen thing. You'll see this and you'll see your a window right above that. So since I'm wanting to graph, I'm going to go to the y equals. Mine still has stuff there, so I'm going to clear and hit enter, clear and hit enter. So I'm ready to plot the first one, which I think was -x plus 4. That might have been the second one. Order doesn't really matter, but keep in mind, I just said -x, not subtract an x. Make sure you're pushing a negative when you mean a negative. So negative, the x is right next to alpha, and then plus 4. I'm going to hit enter so that I can do my second equation, which is just 4x minus 1. So 4, the x's again, the button right next to alpha. And then I'm saying subtract 1, not -1. So I'm pretty sure those were the two that I was looking at on this problem. I'm going to hit graph. I see my two lines. I see them intersect in quadrant 1, but to calculate it, you'll push second and then the little word calc right there. So second and then your trace button. Second, calc. Specifically, I'd like to calculate the intersection to know exactly what x and y coordinate for their intersection. I don't really care about this. I'm just gonna hit enter a bunch of times, 3 times specifically. I see the intersection is 1, 3. So when I go back, the value of the x is a 1, the value of the y is a 3, and it was located in quadrant 1, where everything is positive. You did not need to do that for number 6. So several of the questions on this quiz were, hey, this is already graphed. Which things are solutions? So you don't have to even care about these equations. You need to care about the picture, and you need to know that a solution is something that is true for both. And since nothing is shaded, only right here and right here are solutions to both. Those are the dots that are on both the U shape and on the line. So that's what I got to find. So if I just go through my list, if I go to negative 2x and then negative 5y, well, what do you know? I just found the first one. You should have marked that one. If I do positive 2 and then negative 5, well, there's the second one. But then when I just look at what the rest of the options were, if you chose 3, 0, you just happen to find its x-intercept, which I didn't ask about. If you chose 0, negative 9, you found the vertex. You found the minimum point. You found the y-intercept, which I don't care about. And 3, 0, you found the x-intercept. So if you picked any of these, they're important points, but they are not intersection points. That's what I was looking for. And I'll go ahead and put number 7 on this video, and then I'll pause this one. So Dave's solving these with elimination. He doesn't know how to start. He's wanting to eliminate the x. So we have a bunch of options, and I just want to know, would that make x eliminate? Which means, is this going to turn x into additive inverses? And a whole lot of you missed this. This actually is close to the worst question off this entire quiz. So definitely, I hope we're still listening. Maybe I shouldn't have put this one at the end of the video, but whatever, too late now. Part A, I'm just going to read through them and see if it works. Part A says to multiply the top equation by negative 2. So if I do that, I would get negative 10x, positive 18y, and then positive 38. And then multiply the bottom equation by 5. Well, if I multiply this bottom equation by 5, I would get 10x plus 20y, and it would be equal to 0. So I want to know, is that the correct answer? Does that eliminate the x? And if you add right now, we have additive inverses. Those would in fact eliminate. You can finish solving this, and I don't care what the solution is, but that actually worked. So it wasn't really even asking what is the additive inverse or what is the solution. It just wanted to know, if you do this step, does it eliminate what I ask you to eliminate? So definitely try these to see which would be true. I happen to put the correct answer as A. Let's say you had tried part D first. It says go ahead and add the two equations together and the x will be eliminated. So if you tried that, wouldn't happen because 5x plus 2x is 7x, not 0 like what we are looking for. So because it wasn't 0, that is why D was not the answer. So if you get a question like this on your test, try it and see if it works.